All right, guys, I wanted to do a quick review for those of you who, since I was out yesterday, for our review. So this is the review for the right triangle retake. All right, so question number 1 is asking us to consider this right triangle. So here we have our angles, and so it's asking us to determine whether each equation is correct or not. And so I just want to remind you, for these, we want to make sure that we look at the angle itself. So the first two angles that we have are angle E. So here, right, so here if you look, oops, sorry, my pen's not working. So you have angle E, so I want to reference angle E, and then you're going to go ahead and label all of your sides based on angle E. So directly across, we have our opposite side, directly across from the 90 degrees. And so if you guys see the 90 degrees is here, is going to be our hypotenuse, and then therefore the last side that is touching the angle is going to be our adjacent side. Okay, so if we look at it, our sine, and so remember, sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and then tangent is equal to opposite over adjacent. So here we're looking for sine. So sine of E is going to be opposite, which is 12, over hypotenuse, which is 13. So if you guys see, that one is correct. Okay, then we have cosine. So cosine of E is then going to be adjacent. So we have 5 over 13. Okay, and so if you see, this one's over 12. So that one's a no. Okay, all right. And so now we're going to look at angle G. So then we're going to have to go ahead and look at angle G. And so if we look at a different angle, then we're going to have to relabel our sides. So now directly across, now the 5 is our opposite. Okay, the hypotenuse is always the same, and then the adjacent now is going to be the 12. So if we want sine of angle G, opposite is going to be the 5, the hypotenuse is going to be the 13. Okay, so if you see here, it's 13 over 5, so that one's the opposite of what it should be, so that's going to be a no. Next, we have cosine of G. So cosine of G is going to be the adjacent. So for the adjacent, we have 12. For the hypotenuse, we have 13. And so once again, we have 13 over 12, which is the opposite of what it should be. So that's also going to be a no. All right. So we have, sorry, let me go ahead. We have a yes, a no, and a no there. All right. This one here, very similar. If you guys can go ahead and do it the same. All right, for number 3, it says the school district is building a wheelchair ramp at the front of the school as shown below. So enter the height of the ramp in feet. Okay, so we're looking for the height. Okay, and so we're going to go ahead and use the information that we have. So once again, what we want to do here is identify our angle. We know that our angle here is going to be the 15 degrees that is marked here. Straight across is going to be our opposite side, okay? Straight across from the 90 degrees is our hypotenuse, and then the side that touches the angle in the 90 degrees is our adjacent side. We want to come up with a trig problem. So remember, anytime that we have an angle, we know we're going to use our trig function, sine, cosine, or tangent. We want to find the height, so that's going to be our opposite side, and then we're given our hypotenuse here. Okay, so here I have opposite and I have hypotenuse. Excuse me. So here I know that it's going to be sine, and so sine is equal to the opposite over the hypotenuse. So sine of the angle, our angle is 15, is going to be the opposite, which is h. That's what we're solving for, and then the hypotenuse is the 25. I want to be able to solve for h, so I'm going to multiply both sides by 25. Okay, 25 cancels out, and so here h is equal to 25 times the sine of 15. Okay, and so now I can just go ahead and go on a, go ahead and close this one off. I'm going to go into Desmos and I can plug that in. And so here I want to use a scientific calculator. So once again, I had 25 times sine of 15. Okay, and if you guys see, that gives me 6.47. So if I go back to my answer there, it's asking me to round to the nearest, to round to the nearest tenth. So if I have, 6, so we said h was going to equal 6.47, the nearest tenth, we're looking at the 4, so we look at the 7. Because it's 5 or more, we're going to round up. So here, our height is going to be 6.5 inches. Or not inches. It says, enter the height in feet. Round the answer to the nearest tenth in inches. It should be in feet, sorry. That's written incorrectly, so that should be feet. Okay, so 6.5 feet there. All right, let's go ahead and move on to the next one. All right, number 4 here. So it's asking us to consider the right triangle, and it's asking us to determine whether the expression can be used to find the side of the length TV. Okay, so side TV here, if you guys see, is going to be the hypotenuse. Right, so we're looking for the hypotenuse here. All right, and then if you see, most of these here are looking at angle V. So I'm going to go ahead and identify angle V, which is here, and then I'm going to go ahead and label my sides based on angle V. So here, 6 is going to be the opposite. Directly across is the hypotenuse, which we already labeled as H, and then the side that's touching the angle is our adjacent. Okay, so looking at V, I'm going to do sine. So I have sine of V is equal to opposite, which is 6, over the hypotenuse, which is what I want to solve for, right? That H, which I'm saying TV is H, right? Right, it's the hypotenuse side. Okay, I want to solve for H, so I'm going to multiply both sides by H. Okay, that cancels out there, so I get H times sine of V is equal to 6. I want that side by itself, so I'm going to divide by sine of V since it's being multiplied. Whatever I do to one side of the equation, I'm going to do to the other. Sine V divided by sine V leaves us with that H, the hypotenuse, is going to be equal to 6 sine of V. So this one is a yes, that is correct. Now I'm going to go ahead and do the same for V, and it's going to do cosine. Okay, so let me just go ahead and choose a different color there. So we're looking at cosine. So cosine of V now is going to be the opposite, sorry, not the opposite, it's going to be the adjacent over the hypotenuse. So the adjacent side here, A, is equal to 8. The hypotenuse is still H.
You came back?
All right, sorry about that. Miss Sanchez just walked in. All right, so we want to get, once again, H by itself. So here we're going to multiply by H. And remember, you always want to multiply by whatever the denominator is. Okay, so here we're going to move it to the other side. And the reason we're moving it is because we need to get it by itself. We cannot get it by itself if it's underneath, if it's in the denominator of the fraction. So here that cancels out, so we get H times cosine of V is equal to 8. We want the H to be by itself, so we're going to divide by cosine of V. Whatever we do to one side, we're going to do to the other side. Cosine of V divided by cosine of V leaves us with H, and H is equal to 8 over cosine of V. And so if you see here, it's 6 over cosine of V, so that's going to be a no, because that does not match what we have here as our final answer. All right, the next one is still in reference to angle V, which is tangent, so we're going to go ahead and pick a different color and do that one. So now for tangent, we're going to have tangent of V is equal to opposite over adjacent. So here, opposite over adjacent, we know that our opposite is 6, and then our adjacent is 8. Okay, so here, remember, it wants us to use these equations to be able to solve for TV. Well, if you see, I plugged in 6 and 8, so really there's nothing for me to solve, and side TV is H. So it says determine whether each expression can be used to find the length of H, right, of TV. TV is the hypotenuse. Well, in our equation, we don't have hypotenuse, and therefore it's going to be an automatic no. You cannot use tangent to solve for the hypotenuse because it's not part of the equation. All right? Now we're going to go ahead and look at another angle. Okay, so here it's looking at angle T. All right, so if we're looking at angle T, now we're going to have to go ahead and re-identify our sides. So directly across is going to be our opposite. So 8 is now our opposite. The hypotenuse never changes. That still stays the same. And then now our adjacent, the side that's touching, is now that's going to be our, so remember this is T here. That's going to be our adjacent now. So we're looking for cosine. So cosine of T is going to be equal to adjacent over hypotenuse. So the adjacent side is 6 over H. I want to get H by itself. So same thing, I'm going to multiply both sides by H. So we're just going to be doing those same steps that we had done before. I want to get H by itself, so I'm going to divide by cosine of T. Whatever I do to one side, I'm going to do to the other side. Cosine of T over cosine of T turns into a 1. 1 times H leaves me with H, and so I have 6 divided by cosine of T. And so, yes, that one will work. Okay. All right, moving along. All right, so here it's asking us to find the length of KL. So length of KL is here. Okay, we're given an angle and we're given a side. So remember, anytime that we're given an angle, we know that we are automatically going to be using our trig function, sine, cosine, and tangent. So directly across, we know is our opposite side. Directly across from the 90 degrees is our hypotenuse, and therefore the other side is the adjacent side. I want to find two sides that are going to give me information about the side. So here I have the hypotenuse tells me that that is 12, and then here I want to know what KL is, right? That's the unknown. So I'm going to use a trig function that includes the opposite and the hypotenuse. So if I know my trig functions, okay, I know that sine is equal to opposite over hypotenuse, and so that's what I want to use, right? I know that cosine is equal to adjacent over hypotenuse. That one doesn't help me. And then I know that tangent is equal to opposite over adjacent. So that one doesn't help me either. So here I'm going to be using sine. So I'm going to have sine of the angle, which is 57 degrees, is going to equal the opposite side, which is what I'm looking for. Okay, so I'm going to call that KL over the hypotenuse, which is 12. I want to get KL by itself, so I'm going to multiply. Remember, I always multiply by the denominator, so I'm going to multiply by 12. That cancels out, so I have 12 times sine of 57 is equal to KL. Okay, and then here, if you see, it wants me to round it to the nearest whole number. Okay, so here I'm going to go ahead and enter that into my Desmos. So I'm going to clear this. So I had, sorry, let me look at the numbers really quick again. So I had 12 times sine of 57. And so if I get 10.06, and so if I want to round it to the nearest whole number, I know that that's going to round to 10. Okay, so here I should have 10. Should be my answer there. All right, number 6 is just like number 4, so I'm not going to be going over this one. All right, here it says that Mark has to determine the height x of a nearby flagpole. He stands 52 feet from the base of the flagpole. The measure of the angle of elevation from Mark to the top of the flagpole is 42 degrees. All right, so here I don't have an illustration, so I want to kind of go ahead and just kind of sketch. So here's my flagpole. There's going to be a flag on it. Okay, I know that Mark is standing somewhere, so I'm going to just put him on this side. And so here from the base, he is 52 feet. Okay, and so here from, it says the angle of elevation. So from Mark to the top of the flagpole, so we're looking here, this is going to be 42 degrees, and that's what it tells me. The measure of elevation, remember elevation means you're looking up, depression means you're looking down. Okay, so here is 42, and we are looking for the height of the pole, so we are looking for this side here. All right, so here it's asking me select which of the following can be used to find the height. So once again here, I want to go ahead and label what I have. So I know the angle directly across is going to be the opposite. That's going to help me find the height. Okay, here, this has to be the 90 degrees. If not, the flagpole wouldn't stand up straight. So that's going to be my hypotenuse. And then here, this is my adjacent. So if you see, I'm going to need the opposite to find the height. And then I know that the adjacent side is 52. If you guys know, opposite and adjacent create tangent. Okay, right? So opposite and adjacent create tangent. So pretty much anything that doesn't include tangent will not allow me to solve here. So sine isn't going to help me. Cosine isn't going to help me. And so here our last two, if you see, it has the angle 42 and it has the angle 48. Well, 42 plus 48 plus 90 is going to give me 180 degrees. So our correct answers are going to be E and F here. Okay, and once again, it's because the other trig functions got canceled out there. Not canceled out, it's just they wouldn't give us the information that we need to solve based on the information provided. All right, let's keep going. This one's very similar to question number 6 here, so I'm going to keep going. All right, so here Jose takes an elevator to the top of the St. Louis Arc, which is 630 feet tall. His grandparents are standing down below 200 feet away from Jose's lookout point at point B. Okay, so it has it drawn for us. Hold on. And then it's asking us to enter the measure of the angle of depression A. So it actually identifies the angle of depression, which is nice. So remember, the angle of depression is going to be here. We're looking down, okay? And so here we need to identify our sides. So if we're looking for the angle, directly across is going to be our opposite. Directly across from the 90 degrees is our hypotenuse, and then the one that side that touches the angle and the 90 degrees is our adjacent. So the information given to us is adjacent and opposite. So we know that we're going to use tangent. So tangent of angle A is going to equal the opposite, which is 630 divided by 200. Okay, so here, if I want to cancel, if I want to solve for A, remember I want to cancel out tangent. So this is going to be our inverse trig function. So here it's going to be tangent. Remember, inverse is just a little -1. Whatever I do to one side of the equation, I have to do to the other. Here it cancels, and so angle A is going to equal to the inverse of tangent of 630 divided by 200. And if I look at the directions, it wants me to round it to the nearest whole degree, so a whole number. Okay, so inverse tangent of 630 divided by 200. So if I go to Desmos here, so I have, and remember to go to inverse, you're going to go to functions, and then I have the inverse of tangent. Go back to the main one to type it in. So I have 630 divided by 200. Okay, and that's going to leave me with 72.38. I want it to be a whole number. Okay, so I know that here my answer is going to round down to 72 because of the 3. Okay, so here, once again, angle A is going to equal to 72. It was 72.38. We want a whole one, so we're looking at the 2. So we're going to look at the 3 because it's 4 or less. We know that we stay the same. So angle A is going to be 72 degrees. All right, so here, A loco 711 needs repairs made for the sign. The angle of elevation from the truck of the sign is 52 degrees, and the truck is sitting 42 feet from the base of the sign. All right, so if we look at the question, it's asking us how long does the arm of the lift need to be in order to reach the sign that to make the repairs. All right, so what we're looking for here is the arm. So we're looking at this one here. All right, everything else is already labeled for us. So if I'm looking at the 52, directly across is my opposite. I'm looking for the hypotenuse here. Sorry, let me make that look a little nicer here. Looks like the A. So here is the hypotenuse, and so here now we have our adjacent side. So we have the adjacent side and the hypotenuse, so that's going to be cosine of our angle, which is 52, is going to equal the adjacent, which is 24, over the arm. I'm going to call the arm H here for hypotenuse. I want to solve for H, so I'm going to, once again, always multiply by the denominator. So the H's are going to cancel out. So I have H times cosine of 52 is going to equal 24. I want H by itself, so I'm going to divide by cosine of 52. Whatever I do to one side, I'm going to do to the other side. Okay. Cosine of 52 divided by cosine of 52 turns into a 1. 1 times H leaves me with H. And so here now I get to put this back into Desmos. So 24 divided by cosine of 52. So, oh my goodness, sorry, I'm very forgetful. My sides were 24 times cosine of 52. So 24 times cosine of 52, and so that leaves me with 14.7, and so it wanted me to round it to the nearest foot. So if I have H is equal to 14.7, the nearest foot here, I'm looking at the 4, so I'm looking to the left, to the right, which is a 7, and so here the length of the arm has to be 15 feet. Okay. All right, here number 11, it says the top of the tree broke and fell over. The remaining tree trunk is 5 feet tall. The tip of the tree rests on the ground 12 feet from the base of the trunk. A diagram is shown. So here, if you see, we have the 12 feet, the 5 feet, and so it's asking us to find the length of the broken piece. So if you see, that's going to be here. Well, we're given the other two sides, and so if we ever have to deal with only sides, we know that we're going to be using Pythagorean theorem. So we have a squared plus b squared is equal to c squared. Remember, a and b are going to be the legs, and c is going to be the hypotenuse. If you guys see, h is going to be the hypotenuse here. So we'll have the 5 squared plus the 12 squared is going to equal our h squared. 5 squared is 25 plus 144. It's going to equal h squared. So here it's going to turn into 169 is equal to h squared. To cancel out that squared, we're going to square root both sides. And so here our answer should be 13 feet. All right, the value of the hypotenuse to the right. So once again, here we're going to use Pythagorean theorem. A squared plus b squared is equal to c squared. So you guys can use that one. 13, this one, it looks complicated, but once you read the question, it's not that complicated. It says in the triangle shown, what is the length of BD? So here, BD is here. So you know CD is 3. You know that BC is 5. So really, you don't care about that triangle. So the only thing I care about is this is 3, this is 5, and I want to find this other length, so I'm going to call it x. Okay, so once again, if I'm working with all sides, then I can use Pythagorean theorem. A squared plus b squared is equal to c squared. Here, if you know, directly across the c is going to be the 5, so I'm going to have x squared plus 3 squared equals 5 squared. x squared plus 9 is equal to 25. I want to get x by itself, so I'm going to subtract 9. X squared is equal to 16. I want to get x by itself, square root both sides, and so x here is going to be the 4. All right, and so I'll let you guys finish the other ones on your own. Feel free to come to tutoring if you have any other questions.